Here in example 2, they're asking us to interpret the graph of the proportional relationship shown. The graph shows that the distance traveled by the Mars rover Curiosity is proportional to the time traveled. Interpret each plotted point in the graph. So take a look at the graph in the purple shaded area there. The graph is entitled Curiosity rover at top speed. The x-axis looks at the time in seconds, while the y-axis looks at the distance in inches. So we're talking how many inches the Curiosity rover is going to travel in a given amount of time given in seconds. So 0, 0 is easy to understand. 0, 0 means if we have no time, the rover can't go anywhere, which makes sense. Same thing would be true of anything if we were talking about your car. If you haven't been in your car at all, you can't go anywhere. So that's an obvious answer. So let's look at the other two because those are more interesting. 1, 1.5. Well, if we look at 1, 1.5, that means in 1 second, the rover is going to travel 1.5 inches. Remember, we're talking about something that's traveling along the surface of Mars, so it's not going to go far fast by any means. So 1, 1.5 makes sense. So that means then, because it's also a proportional relationship, that every time I increment by 1 second, I should be able to get another 1.5 inches out of the rover. So if I were to go to 2 seconds, it should be at 3 inches because it's proportional. I've doubled both values. And the same would be true if I tripled both values or multiplied both of them by 4 or by 5 or by 10 or any number I want. They're both going to multiply by that same number. So when I get to 3, 4.5, 3 comma 4.5 means I've traveled for 3 seconds and moved 4.5 inches. Well, notice as you can see there, when they take and reduce that fraction, it reduces down to 1.5 over 1, which comes back to that first set of values, again indicating the existence of a proportional relationship.